Hello, dear guests. Let's give at least a couple of more minutes so people is still joining. So thank you very much for being here today. Okay, thank you very much for your patience and welcome to this webinar. This is one of the many webinars we have planned with Additive Plus and our dear partners. This time we are going to present very cost-effective methods to 3D print technical ceramics and also metals. And we will have, today we have a great speaker and a dear friend, my friend Ruslan, who will tell us more about this very innovative way to work with technical materials and also work with multiple technologies with the same machine. Thank you for being here, Ruslan.
Yeah, thank you very much, Harry. So thanks all for joining us at this webinar. So I will present the cost-effective method of 3D print of technical ceramics today, speaking about our multi-additive technology machine, abbreviation M.A.T. So I will review, just briefly introduce the company, who we are, where we come from, why ceramics, etc. I will present technology, its advantages, and we'll speak about this multi-additive technology, integrating different tools, and we'll also speak about different materials we can print, available ones, but recently developed ones, and we'll speak about new developments of this technology. So the company was founded, 3DCeram is a French company, first located in Limoges, which is considered as a center of technical ceramics in France. We have big R&D center of fundamental research for ceramics in Limoges, but we have also a school of engineers, ceramic engineers in Limoges. So the company was founded in early 2000s by two guys, Christian Chaput and Richard Gagnon. Both of them are ceramic engineers. One is coming, Christophe was the head of big ceramic lab in France, and Richard for many years was at the direction of technical ceramics manufacturing and engineering company. So the company, at first steps, we start to print parts for different applications, mainly biomedical, but also some jewelry. And over the years, we could enhance our printing tool, our printers, and we create our own printers, start from 2010, and changed our business model 5 years ago, 5 years after starting to sell printers, to sell materials, to sell to develop the applications with our customers. 2017, big Japanese group Sinto became our main shareholder, and this provided us more financial and resources to expand our activity all over the world. So the company 3DCeram has right now several subsidiaries in China, Japan, US, but also representative offices in different countries. Recently, 2022, and this is the topic of our today's speech, we integrated company Tivoli Scientific Instruments, who created the technology I will speak about in few minutes. So who we are? We are process provider. What does it mean? It means that we are manufacturing our own printers. Core business is SLA printing technology, so I will speak few words about this just after, but we also manufacture our own feedstock, develop our own software to make it easier to print the ceramic parts because it's challenging, but also render some services going from basic services like training of operation maintenance personnel, but also co-develop with our customers different parts or applications. So as I said, our core business is SLA technology, stereolithography, where it's slurry-based 3D printing technology for technical ceramics. And we have a range of printers we can propose here, going from small C101 lab or fab machine to the big C3600 machine, having the build plate size of 600 by 600 by 300 in Z. So this machine actually is the biggest in the world for printing of technical ceramics. And you can see here kind of strange small machine called M.A.T. It's a new machine, new technology, different from what we are used to do, but it also printing ceramics. So some words about this technology. What is that? M.A.T, as I said, means multi-additive technology. The idea was to design a tool, kind of versatile tool, which can be entrance point to the printing of technical ceramics. So integrates right now different technologies, FFF, fused filament fabrication, but also some subtractive technology like grain machining, robocasting, and during the Formnext, we'll present new technology which will be integrate something about this new technology later. This machine is the common base for different tools. So all this technology, FFF, grain machining, robocasting, etc., will be based, integrated in the same machine, which is about 100 kilos. So it's not really a desktop printer, it's a professional printer, but it's a good, easy, user-friendly machine to start printing of ceramics. Quick swap of tools, excellent quality of the parts, excellent density of ceramic parts is ensured by this machine. Why we integrate this technology? As I said, our core business is SLA, and for many years we are selling SLA slurry-based printers to make our ceramic parts. But this technology, SLA technology, has some big inconvenience. It's not possible, for example, to print dark ceramics with SLA. UV laser-based SLA technology is not able to print these dark ceramics like silicon carbide, but also other materials like because of optical properties of these ceramics. They're absorbing UV lights, and we cannot print really these materials. M.A.T provides the advantage to be able to print these materials. It also provides the advantage to print other materials than ceramics, because this machine is used also to print metals. We have some features, I will speak about it later. It's not color sensitive technology, because FFF, we know how to do the filament in a thermoplastic matrix of ceramics, metals, different composites. This is the only method to print the infills. It's not possible to do with SLA. And of course, it's low investment, it's cost effective, as we said before, technology. So in comparison to SLA printers. Materials we can print and we can sell right now are many. So for ceramics, we speak about alumina and zirconia. This is about 90% of the market. But one of the main materials which is really appreciated for this technology is silicon carbide. So we use silicon carbide, pure silicon carbide. It's not impregnated silicon carbide like CSIC. We also can print some metals like titanium, copper, different kinds of stainless steel on the same machine. Like for SLA and even for traditionally manufactured technical ceramics, printing is just the first stage of the whole production process. So we shape the part during the printing. So we use the binder, in this case it's thermoplastic matrix, using the binder and ceramic powder to provide certain shape during the printing. It means that after the printing, we need to remove this binder and to sinter the part to give it the final properties. So we have chemical and thermal debinding process after the printing, and we have the sintering process, which is in relation to the nature of the material we print. So sintering will be different for oxides like alumina, zirconia, and for non-oxides like silicon carbide or metals. The heart of this machine and let's say the interest for this machine is to be able to print highly loaded filament. When we speak about ceramic filament, we speak about the filament with more than 50% of ceramic or fine ceramic powder dispersed in thermoplastic matrix. To do this, it's challenging because this kind of filament is brittle. So we have from one side, we have to be stiff enough to go through the small extrusion nozzle of FFF head. The nozzle size is between 0.4 and 1 millimeter. And at the same time, we have to be soft enough to bring this filament to the printing head. Please note that temperature of softening of the filament through the extrusion head is lower than for usual plastic printers. This is the difference between any FFF printer you find on the market for the plastic, for the polymers, and this printer. We are working in the range of 160, 170 degrees C. So it makes it necessary to fill, as I said, we have to be stiff enough to go through this nozzle. It means that we have to heat this filament really at the head, at the printing head, and cool it when cooling everywhere before. Standard nozzle of this machine is in brass, but it can be also adapted to the very abrasive material. So we can, in session question and answers, we can answer to this, but we usually use brass. Why? Because it's cheap. We can change it very easily. And just for information, the consumption of the brass nozzle is about 1 kilo of silicon carbide, which is really wearing material. We use also direct radiative heating of the part during the printing, just to enhance the layer adhesion, so to ensure the stability of the printed structure. So this printer provides, because of these technical features, it provides very good ratio between the quality of the parts and stability of the printers. Just for the example, we use this printer during the exhibitions like Formnext, and this printer will be exhibited at Formnext next week. We can print during all the day without any stoppage due to the clogging of the nozzle. Those the features I just described was for the basic version, able to print ceramics. But as I said, this machine is also able to print metals. And to do this, we have premium version of the machine. This premium version is equipped with some additional equipment like heating of the filament reel. The filament reel is located in separate compartment, separate section, which is preheated up to 30-40 degrees. This is to soften the filament when we handle it, when we feed it to the extrusion head. We have also some more sensors, temperature sensors inside of the chamber, because we can preheat the chamber for the printing of some metals, for example. Preheating of the filament is very important, it's critical, let's say, to avoid any stoppage, because again, note, the filament we use is very high loaded, 50% more of ceramic powder. So to do this feeding, we need to have soft filament, but stiff enough to go to the extrusion head. Some materials can generate nocive pollution during the printing, especially we speak about stainless steel, for example. So to fight with this, we equip our machine with the filters, which remove about 99.99% of particles bigger than 300 nanometers. So this is required by printing of metals, if you wanna do both ceramics and metals printing. As I said, this machine was designed as the versatile tool, kind of common base for integration of different technology. One of these different technologies is CNC, green machining tool. Why CNC? First, green machining provides better density and surface finish of the part, but not only this. You know, to print, when you print some abrasive, really abrasive materials like silicon carbide, if you do this machining at the end, after the sintering, this process is very, very wearing. The material is very, very resistant. So it's very difficult and costly to machine the sintered parts. Green machining can be a good alternative because we do the machining on the contour of the part after the printing. And this allows to do the machining with less efforts, better quality, and we can enhance not only the surface finishing, but also the density of the part. Why? Those who know the FFF printing or FDM, it's the same. Note that we have some drawback when we turn the direction during the deposit of layers. We may have some porosity. We have this porosity on the surface of the part, or just under the surface of the part. So to remove this, green machine is a wonderful tool because it's not only enhance the surface, but also removes this porosity and provides better density of the overall part. Here you can see the small video of the machine tests. Of course, you will not see all this debris on the build plate because this CNC tool is coupled with the vacuum cleaner, but just to show how we do this green machining. To know that right now we do the green machine after we print the parts. So the part is there, we fix the CNC head in 5 minutes on the printing head, and we do our green machining. In the future, we are working in combined process when you print and machine at the same time. So this is to come. Here, the explanation, some small diagram about the porosity I was talking about. So you can see on the right side of the pictures why green machining enhances the surface finishing. And on the left side, you can see why it also enhances in some way the density, the overall density of the part, because of the small porosities we have at the drawback of the filament. Robocasting tool is Archimedes screw extrusion head used mainly for R&D purpose. We do not provide the feedstock for the robocasting, and the main purpose of the robocasting is to create the material which is water binder based. No debinding, no polymers, just drying. Of course, it's a challenge to find out the right viscosity of the material, to ensure at the same time no dripping, no oozing of the material through this screw. So we use some special design of the screw to create some drawback, screw drawback before the final deposit of the material, but also to ensure the right deposit of the material, the right building of the part. So this tool is already available, is already proposed with the machine. And of course, it can be also combined with the green machining tool I just described it just before. About the materials, when we supply this machine and when we supply these materials, we don't only provide you the materials and you try to print with, we guarantee the quality, the final property of the ceramic parts, provided you respect, of course, the sintering conditions necessary for each particular material. So all of our materials were qualified, characterized by independent organization like European Space Agency or Fraunhofer Institute in Germany. Here, the example for this characterization of silicon carbide. As I said, silicon carbide is one of the ceramic material for which was the main reason of integration of this technology, because we are not able to do this with SLA. And this material is very required on the market. It's very hard. It's very well resistant at high temperature. It has good thermal and electrical conductivity, low thermal extension, etc., etc. So many applications for these materials. It's going from setters for semiconductors and solid fuel cells to aerospace and defense industry and optical instruments, of course. Some pictures, some photographs of microscope photographs of the printed parts, so you can see the layers. In this case, it's 75 microns layers printed with 0.8 millimeter nozzle, so we can do better using the smaller nozzle. But this smaller nozzle, the choice of the nozzle, in fact, is a combination. It's a compromise between the speed of the printing and the accuracy you want to have. So in this case, you can see very homogeneous dense structure of this part. Of course, you see the filament traces, you see the filament structure, which is for the parts as printed without machining. But this structure is very, very homogeneous and dense. The density shown here on the next photo, on the next slide. And this density is about 70% of the theoretical, 97%, sorry, of the theoretical one. Again, we use pure silicon carbide. The only additive we provide we give during the sintering is just 2%, I think, of boron nitride to help the sintering process. Otherwise, the material is pure. It's not CSIC, it's not NSIC or another material like this. It's silicon carbide pure. Mechanical strength of this material, of printed material, is about 400 to 500 MPa. So this goes in line with the density we just saw on the previous slide. And here you have the summary of all these properties. So you can note also thermal conductivity of this material at 20 degrees is something in between alumina and aluminum nitride, which can be a good compromise as well for some electronics applications. The flexural strength is more than 400 MPa. Bulk density is about 70%. And of course, for those who are interested in these materials, we can provide the full complete data sheet specification of these materials and recommendation how to sinter it. As I said, this machine is able to print also metals. So one of these examples is titanium. Also, this material was characterized and qualified by European Space Agency. So the quality of this material is airspace, so-called airspace grade. We have about 940 MPa of tensile strengths, and these materials can be also printed and machined in green stage just after the printing. The same. For those who are interested in this material, full specifications can be provided in private exchange. But those, I mean, the materials I described, ceramics and metals, are not the only materials which can be printable with this machine. Here is study case, some development of electrically conducting ceramic materials. So this is MOSI2. We did with the German Institute, R&D Institute, Fraunhofer Institute. So the same, this material, the development of new filament can be done. We had this cases with some other customers, so we can also do on-demand development for the material, new materials. It can be electrically conductive ceramics, it can be different metals, it can be very, let's say, exotic ceramics used for very particular applications. So development time is usually takes about 1.5, 2 months, depending on the shape of the parts, size of the parts we can do or we want to do, and depending on the powder properties we have. Example of such new developments are ferrite and cordierite. So these are new materials we could develop this year with some of our customers. So you have some examples of parts we could print with this machine. So again, we speak about FFF printing, about filament printing, and of course, all these parts can be also machined with a CNC tool. To come, new developments. During the Formnext, we will show the pellets extrusion. So this is another tool we add to this machine. We will be able to integrate to this machine. Pellets extrusion is also interesting for some applications. And the perfect idea is to use the same feedstock, the same material, use it for the ceramic injection molding. So this can be interesting for some people who is already involved in ceramic injection molding and who want to print some prototypes, develop some new parts, new products, because we don't have any tools, just digital tool, software to print the new parts. So this will be proposed and described after the Formnext. So this is all about my presentation. Thank you very much, and I'm at your disposal for any questions. So please feel free to ask if you need some more information about this technology and the machine. Just to add, because I missed this in my presentation, the size of the printing chamber, in this case we speak about the printing chamber, is 200 by 200 by 200 millimeters for this machine. Thank you very much.
Thank you very much for your excellent presentation, Ruslan. Please, if someone within the attendees have any questions, please feel free to ask to Ruslan. In the meantime, I have one quick question about the system. In any case, you can work with advanced ceramics, but what about the open parameters of the machine? Is this machine closed, or you can have open capabilities for to use any material?
Yeah, thank you very much, Harry. It's very good question. So yes, our machine is open parameters. So we are typically using software Cura, which all the makers know. This is something everybody is using. So we do not have some locking. It's not locked to our materials. You are not obliged to buy the materials from us. But of course, our materials will provide necessary guarantee of properties, which you may not have with other materials you purchase on the market. So this is the main advantage. But all in all, our machine is fully open. So you can choose, you can work on your own parameters. The machine is open.
For the post-printing properties, the chemical and thermal and sintering post-printing, are those bands wide enough to allow for multi-material printing? For instance, could you print titanium clad in silicon carbide, or would the sintering destroy that?
Well, we are not. This machine is right now, because maybe it can. We may have some development in the future. This machine has only one printing head, so typically we can print only one material. We cannot do multi-material printing like what we do with the SLA technology, when we have two different materials print in one layer, for example, or if you print some sandwich structure. So we can imagine that during the R&D works, you change the filament and you print, let's say, one layer of titanium, another layer of SiC, etc., etc. But of course, the main challenge in this case will be the co-sintering of these materials, because they have different nature, they have different shrinkage, they will have different properties. And if you sinter them in the one kiln and the one cycle, you might have issues. So, but this is not in relation with the technology of printing technology we use, but it's just challenge of multi-material technology itself. We have developed multi-material printing for SLA printers. We could develop with some of our customers HTTC and LTTC materials like alumina and tungsten, or alumina and silver. So we could find some, our customers, because we do not develop this, we do not have skills and expertise in this post-process. But our customers could develop some these materials and print them with SLA. So I can imagine in future we have something, if this evolution of this technology goes into multiple head printer, something like that, we can imagine this work is to be done. Co-sintering is real challenging for these materials.
Thank you.
I think we have some questions in the chat. Can also reach out. Okay. Yeah, you're welcome. Sorry.
No worries. Mr. John is asking if we can share the slides. We will be able to share the presentation.
Yes, of course.
Thank you very much, Ruslan.
And for those who will attend Formnext, I invite you to visit our booth. We will have this machine, as we will have several SLA printers on the booth. It's C33 hole, I think it's 11.1 in Germany, in Frankfurt next week. So this machine, M.A.T printer, will be in operation. So you will be able to see the printing, to see the parts, of course, the quality of the parts. It's really something as I said, our core business is SLA technology, and SLA technology particularity is the high quality, the high density of ceramic parts. So this is really something we really target, and we integrate this technology because of the quality of the parts. stability of the machine, of course, but also the quality of the parts and density of ceramic is very important for the applications.
Great, thank you very much, Ruslan. I have one other question. Is this well, 3DCeram does only provide the printer or also the post-process equipment? And also, I want to add one more question about what is your experience with the medical market and the aerospace market? Thank you.
Okay, this machine is, as I said, it's a good entrance point to print ceramics, so it's not industrial machine. You cannot use this machine like you use SLA printers. You know, one of the arguments of the SLA technology is scalability, because we can develop something on the small machine, we can scale up to the big one and increase the output and break down the costing of the parts. This machine is not used really for industry, it's used for the prototyping. So you learn with this machine, it's good for academia, it's good for research, development. So this is the point to understand. For the post-process equipment, we can supply the full line, including the post-process kilns for debinding and sintering. The only thing that, as I said, we do not have expertise in some specific sintering of silicon carbide, for example, for non-oxides and metals, typically. So we can provide sintering and debinding furnace for the oxides like alumina, zirconia, but we can guide you for the to some vendors who are really specialized in some specific kilns for silicon carbide or for metals.
Great, thank you very much. So is there any other question?
If there's no questions, so you are always welcome to write me, to write to Harry, who will forward you messages if you have some more questions after. So we'll be pleasant to answer you.
Great, thank you very much for your excellent presentation, Ruslan. And we hope to have future webinars with your where you are the speaker. Thank you very much for today. So I would like to take the opportunity to present a bit about our company. We are proud resellers of 3DCeram in the US. And also within our technologies, we work also with technologies for additive manufacturing of metals and metal powder atomization. We under our capabilities is to produce like tailor-made metal powder from custom alloys. Also, we are providers of resins technologies for ultra-fast 3D printing, and also for ultra or super polymers 3D printing like Ultem and PIC. And I would like to say thank you for everyone who attended to our today's webinar. And please don't hesitate to get in touch to us in case you need anything, or if you want our advice on any of these technologies. Thank you very much.